My name is Amy Hodler. I'm your host. We are very lucky today to have Jason Grafft. We're going to learn about skills evaluation using graphs to help kind of embed the context and some of the processes so that you can learn on those. Jason is a friend and former colleague, machine learning engineer focused on truly relational data, so I'll say graphs. Lots of expertise and experience in psychomotor learning, which we'll learn a little more about. I always enjoy having Jason on and speaking with Jason because he's probably one of the most mathematically creative people I've been around. And so I always walk away learning something and thinking about things differently. One of the fun things about Jason's background is he actually has I don't want to say unusual, but different expertise than you would normally find in a machine learning, engineer. I would say 17 years experience in skills evaluation and patient-provider interactions and first responder emergency background as well. So with that, Jason, thank you again for joining us, and I'll let you take it from here.
So thank you, Amy, for the introduction. If you've come here to this and for GraphGeeks, you've come to the right place. Thank you. That was a flattering introduction. Recovering from it a little bit. Thank you, Amy, and thanks for having me on. There's a few more people to thank here. You do not do your best work alone, so these are some of my primary collaborators. Amy has been wonderful to talk about recently and help me brush some dust off this idea and bring it to you as you will see it today. Dr. Remskar is my former boss at the University of Minnesota. She was also the boss of John and Alex. We were part of what is now M Simulation, and Dr. Remskar was my primary collaborator in some of this methodology. John and Alex were very helpful in their both support of our simulations and in their expertise in them, John in particular. Alex at the time was not a DO. He was finishing up his bachelor's degree in physiology and looking to move on. Marty is the former director of Hennepin County EMS. If you heard about the 35W bridge collapse, he was one of the senior people in overseeing that. And if you ask around town, he is one of the reasons that it was so successfully handled. He helped review this and gave me some critical feedback, which was extremely helpful. To give you some idea of Marty's acumen in the field, I probably would have shelved this had he not been impressed. And lastly, my father is Joe Grafft. That is not an accident. I was Joe Grafft's son for the first 5 years of my career in EMS, and he's been helpful in collaborating and developing this, and he has a hand in how I kicked this off, which I'll tell you the story in a minute. What else we should know is I'm going to put a bunch of content on these slides with the intent that you have something to look at later. So don't worry about reading everything. We'll give you links and I will give you a summary. Like Amy mentioned, I'm talking about healthcare. If you don't have a background in it, that's okay. The relationships are what we really need here. This is a generalizable method, and that kind of makes it easy to miss. The really hard part of this was getting data aligned with a data model, aligned with an implementation, being able to produce something that was more than a picture. I'm going to show you a lot of pictures today. There's more behind it. There's a repo. So hopefully you will take my word on that. You're not going to see this because it's already embedded, but that was the really hard part. So if we want to throw fancy methodology at this, we are now enabled to. That took a really long time, to the point where I hatched this idea almost 20 years ago. And I've seen very little progress on it since, despite bringing it around the country to many places. So that's the background. And here's the outline. We have a problem of observing complex systems, and I will talk about what that means in this context briefly before we go on to talk about what it means to model a psychomotor evaluation or examination. I'll use those two terms interchangeably. Psychomotor is a term used for, can you do something and justify it? You can think of it that way. That's a bit loose, but it works. I will take you through an introductory example of what we mean when we say we're going to model this process. And then we will take a look at the case in question. This will leave a lot of questions about sparsity, and rightly so. That needs to be handled in a specific way here because of the nature of this testing framework. And I do want to emphasize this is a testing and evaluation framework that's important to the result. So we'll talk about how to increase the fidelity of the results as a problem of increasing the quality of inputs and increasing the veracity of how we understand outputs. Then we'll re-summarize that, and you can all be done hearing me talk. So this is where we're at today. We have a really bad model based on a practice that codifies a lot of risk under the rug. Okay, and that isn't a good one. There's a lot of practical reasons for this that have to do with resources and personnel and human factors. And it's a lot more understandable than these couple slides make it sound. But there is a problem, and it is affecting us quite a bit. What is that problem? The problem is observing complex systems is a pain in the butts. And so what I want to emphasize here, because we will see this later, and you'll have to take my word that this is non-contrived, but you will see this shaped like a dumbbell property. And these equilibrium structures at one end, and these non-equilibrium forms in the middle. We will see that, and that is a common feature of this type of decision space modeling. It's really awkward computationally for that reason as well. This is also a very good point, that when we get too reductionist, when our models get too strong, we lose the sensitivity to complexity. We fail to detect it. In this case, it's important. Complex systems as increasingly complicated histories of broken symmetries. When you're talking about patient care and very scary statements like, when I put 3 drugs into someone, I don't know whether it's an adverse reaction between 2 drugs, 3 drugs, the patient and 1 drug, 2 drugs and 1 patient. And that's my boss talking, who's one of the most respected anesthesiologists around. It gets worrisome about not having this kind of clarity. And what happens is you have to accept you never will. You have to accept that this is the frame we're working in, and it's complicated by default. We can simplify it in some ways, but as mentioned earlier, we have to capture that complexity. So we have to be careful about simplifying it too much. And I want to give you the frame of oversimplification, which is up here, because that's much easier to think about. So what we really have is a quantum type observation. And what I mean by that is quantum 101, the really boring stuff, where there's a system moving without you looking at it, and then I'm looking at it, and then I'm not looking at it anymore. So the only thing I understand about that system is between the endpoints of my observation. And that is exactly what's happening in patient care. When I talk about pre-hospital care, where I came from, acute and emergency care, this is a real problem. Back here is why you called me. And now I got to figure it out. But not only am I trying to figure it out, I'm also making interventions that fundamentally change the observations that I make along the way. So we are breaking that history constantly and trying to understand it. And so we need to understand that one observation to one intervention to one observation is really bad abstraction of a complex system. And even this kind of linear representation is a bad abstraction. But we do need to start here. And we need to understand that we're going to interleave and mix observations with interventions, and we're going to convolute and pollute the field on ourselves rather heavily and readily. Researchers go nuts. Medicine, we call that normal, especially if you come from the acute care trades. A hot mess is a normal day, and we do not get this kind of clarity, so you deal with the hard parts, the complexity, this limited sample window problem. However, one of the just fundamental antagonisms about modeling this process for me was that our observations are effectively linear. Time linearizes what we observe, and that's not helpful when you have a really complex decision space, and you'll see what I mean in a second. So the last thing I want to leave us with here is this is very often what we are dealing with when it comes to real world quote observations. We have a group of observations, excuse me. Then we make a group of interventions. Then we have another group of observations, and that goes on. So hopefully you forgive me for not putting something that complicated in the big picture. But that's the kind of way to think about it, is we are continually mixing our observations and interventions, and they are all influencing each other. Do not worry about understanding all the arrows and lines in this graph. If you're familiar with a Markov chain and hidden Markov layers, that's what this is. And you know to look away. You know to look at something else now. What the point of this is it shows that when I show up, I know very little, but there's still effects in play. I make one intervention and then another observation. And as I continue forward in my observations and interventions, that field becomes progressively more confounded. You can see the complexity builds. Well, one of the really weird properties about this problem is that eventually it looks like the left side again. So the left side turns into the middle and turns into the right. And I'll show you kind of what that looks like in a second. But the problem that I have as a provider is I don't get to take interventions back. So once I do something, it becomes part of what I have to deal with next. This is why I need to be so careful about who I send into the field, because we have these intrinsic risks. This isn't going away. We don't get this for free. We're just calling it priced in. And that's BS, period. So we can control it a little bit, but it is non-negotiable, especially when you're in healthcare and somebody's already has a problem. You don't negotiate with the conditions of that problem. You start where the patient is at. The problem we have with training people to be that kind of flexible under that kind of unreasonable pressure, especially if you come from the acute care trades, no amount of training will get you ready for the intensity of what you experience next. But I do need to make sure you can think about this effectively. So how do we do it? We do it like this right now. This has been my whole career, and I'm going to kind of rehash this a couple times, this view. But if you keep this checklist model in mind, this is what we are trying to both supplement and overcome. And yeah, that's a contradiction in terms, but when you use math, those things are less hard constraints. So what are we looking at? We are looking at that same thing here in between the red vertical lines. What what we're now seeing is the view that my observer has. And when I was running EMT programs, the view that I would get from my evaluators. So they would have a checklist and they would have criteria on the checklist, things to observe, things that were done, and they would check those boxes. And, people's names would go up here, and then we'd, maybe sign it down there. And, that was your result. Okay. And so they would keep going, and I would just get stacks of these evaluations. And we have a cut score of 70%. You can see that everybody passed. No, I disagree. We just don't have the mechanism to contest this until now, and I'm about to show you that. So here's the story I promised you about where this method comes from. My first job in my professional life was at Riverside Community College in Riverside, California. It was with the director there, is a man named Chris Nolet. He is retired now. He is a well-known educator in EMS, and so it was quite exciting to go work for him. He also happens to be a family friend, and so when a job came open and I was able to apply for it, I was pretty well qualified, and everybody liked me, so they brought me out. And we had a summative exam for our EMT students, which is the program that I worked with. And this was one side of it, which is where we would take these checklist results. And the other side of it was you would take a cognitive exam. When I say test, it's the one you're thinking of. Multiple choice questions kind of thing. And Riverside Community College under Dr. Nolet had a policy that if you did not score 90% or above on this cognitive exam, we would have to remediate, and we would not be allowed to sit for the national board exam. So he and I got in an argument over the validity of both that exam and what we could do to supplement a process that we could both agree had a lot of holes in the validity. So he asked me, hey, what do you think you can do? And this is kind of what I came up with. I wanted to model the process. And the best model for process when you have a structured set of observations I could find is computer adaptive testing. So what is this? This is the GRE. This is the MCAT. This is a lot of the ACT, SAT models that it's gone to. It is a very on-the-rails experience. They are highly architected, which means they have a very curated information space. So every time we add new information, we can tell what it helps establish our trend, excuse me. So we start with no idea of where you're going. We give you, say, a difficulty 3 question. You answered successfully. So we give you another difficulty 3. You answer that successfully. Then I might bump you up to a difficulty 4 and you do not answer that successfully. So I bring you back down to difficulty 3 and we get cruising on 3 again. And then I bring you up and you get a 4 right, and then you get a 4 right, and then you get a 4 wrong. So I try you on another 4, you get 2 failures, and I bring you back down. So that's that trend of success that I mean. And the floor performance here, this candidate is trending toward a 3 difficulty. There's a lot behind that statement. It depends on the exam you're talking about. I'll speak to that in just a sec. But what is important about that is we have a way of saying that this candidate has reliably performed at or above a validated or a validatable threshold level. So what do we need to do that? What do we need to back that claim that a candidate has or has not trended above a certain score or floor condition? We need a time series of event data because we're not doing computer adaptive testing anymore. In the cognitive sense, we're doing in the observational sense. So I need time and events. And in the adaptive computer world, for the cognitive tests, we would have response in here. That would be your response to the item. But I'm measuring a series of times and events, and that's it. These events and the context of those events are going to live elsewhere because it's too complicated to do this in real time. So we're going to put those things in a graph. That is our set of possibilities. And this ends up working out great. This relationship is symbiotic in a lot of ways, and it gives us a very nice way of establishing probabilistic relationships downstream. I will not talk about that, but to Amy's question about the dumbbell structure and why that it was both important and a problem, establishing probabilistic and structurally valid inference relationships in a clouded information field is a nightmare. And if you're doing it for testing and validity purposes, you cannot throw a low precision tool at it and call it a day. You have to be able to validate it. So that is why we need some constraints. We need to be able to apply these constraints to something. Graphs work the best for that in this case. We need something to do with this time series. That was a real stumper for a long time, but I did find a solution. And then you need a lot of money. In 2009, the group I was working with when I was at the federal government found that it was going to be about $10 million to establish baseline validity for a cognitive exam. And if we're talking about a psychometric exam where it's much harder to scale and much more expensive per unit to scale, to actually validate these things is a huge undertaking. There are ways to do it, but what we really need right now is auditability, which is a much lower threshold. And so if my auditable chain doesn't give me a pathway to psychometric validity, we should really think again, because the expense of scaling up is a very good motivating case for investment in data infrastructure. And if we don't have a good way of making that scale up, it's not going to return investment. There's low margins here. That's somewhat of the backstory, but we want to make sure that when we psychometrically validate an approach, we don't need to change it later. That is the kind of the overarching message. So doing that is a very orthodox process when it comes to research and development. We need starting conditions, we need a model, and then we need to go about validating the model. So here's our starting conditions. We have this graph of all possible orderings. This is the dumbbell shaped thing I keep promising to show you. We absolutely eschew time-based ordering because they're too strict. Having all this bundle of relationships will help us reconstruct the context for the fully ordered set we are going to collect. And in the structural antagonism here is not to be taken lightly, as the stuffy and boring old textbooks warn. Right? We have a linear structure of events and nodes that is obligately ordered, and we have this really wacky structure for an experiment. And we need to have all these raters around who are somewhat qualified to do their job because they've been successful in another role. It's questionable to the point of dubious whether field experience, so to speak, in your trade makes you a better evaluator. I'll leave it there. That's a long topic, but that statement does hold. So we got to figure out how to undo this problem that humans are fundamentally inept at complex repetitive observation. That is actually a starting condition because it's our chief threat to validity. Raters have trouble paying attention even when it's easy, because then they check out. But if I give them all sorts of tools, if I give them something that looks like this, where they're making stuff up all the time, I've degraded their attention even more, and that's not helpful to anyone. So that's current practice, and this is kind of what we do in current practice. So you saw those checklists. This is what those checklists look like as a graph. And I would get stacks of these. UCLA is a great example. When I worked there, we had about 40 students per class. We ran 1,200 students through a year. You had to test 5 skills, and you had 3 chances to pass each skill. So do the math here, and that's what I potentially had 1 stack of these for 1,200 students a year. And I had to tell them apart, right? Like, it doesn't really help that, like, hey, this is not a good thing. Hey, oh, that one's not a good thing either. Hold on, right? Like, let's check. Okay, that one's okay. Oh, there it goes again, right? Well, we found him. Now, what does it mean, right? Oh, crap, here's another one. Shoot, that doesn't look so good anymore. Oh, here's another one. Shoot. This is what we did for years, and you can imagine the debates that happen in this kind of ambiguity. So what do? Well, we can try to put some larger context over this, which is that triangle-looking thing, or the hourglass-looking thing here, which says, like, these are all the things you can do. And then those are the green lines and the structure. And then the purple lines are the things that you did. And we've overlaid everybody's performance here on these graphs, and you can see that, okay, so there's missing some context. That's a little better. So we're getting an idea of what the navigation of the information space is in a summary sense. That's still ambiguous. It's better. It still does not help find this edge. It makes it a little bit easier to look for the ones you want because they're now at the top and bottom of the graph. But if you're doing this by hand, or you're trying to do this in a manual way, or even trying to compute over this, no thank you. We need a better way to do this. And we really need to automate this essential logic to not have people deal with it. We have an optimization that lines are really easy to parse when they come in, because all we need to do is say, if we're at A, well, there's only 2 places we can go. So we can start to flag everything ahead of time. We can start to automate some of these expectations or wants. And then we can make the graphs look like this. And so this is a lot more useful as an evaluator. This is a lot more useful as a reviewer when people want to improve their own performance. That I can say, look, you violated a constraint here, and that's a critical. You can't do that. We got to have you do this again. Okay, this isn't bad, but it's undesirable. And we're a little more skeptical of it than just missing a step down here. So we want to check both of these cases. But now we have a way of saying, like, this is worse than this one, and this one is okay. And when you have lots of people who want to argue about how well they did and lots of opinions weighing in, being able to deconstruct results into how constraints were met in the context of a global decision space in the abstract terms is really helpful. And I'll show you what I mean by that when we apply to a case in just a second. But what I want to do here is point out that not only are we coloring edges, we are establishing the grounds for probabilistic inference, because I can take a lot of these results and I can start to stack them, and I can see where the common pathways are. I can look at things like betweenness centrality as a off-the-shelf grab to see what kinds of pathways are very popular, what kinds of common understandings might exist in my class, what kind of common interpretations were made of a case. It allows me as an evaluator to take a case which we probably didn't write well and it took a long time, so the quality suffers, and look at how people will perform in it, decide whether those are acceptable constraints and acceptable outcomes, and then it gives me a way to start making changes to it in a coherent, structured fashion. Because not only do I have a good presentation of the information, I have the ability to deploy mathematical and statistical tools on the structure that I now capture. So how do we take that out of the toy example into a real world example? So I'm going to give you a structured case, what we would call a standardized patient contact. What I want to point out about case evaluations is they are hyper simplified, and that is done for a specific reason. The decision space is extremely complicated, and if we made people account for everything, we'd lose the point. So we simplify to help see that essentials express, and that's where it becomes problematic, because my opinion on what and how essentials express is probably different than yours, and probably different than yours, and probably different than yours. Then we're going to get in debates. If we do our homework and do it right, we'll leave the debate in the design room, and then we'll go collect data. And that's how we're going to do that. So let me orient you to the case, and then I will show you how we can take meaningful information about how people perform on this case. So remember, the context is me talking to my boss. How do we know that our exams have measured things they should? And we can say that we have made you repeat your education or parts of your education validly. Well, we have to start by assessing how you navigate something that approximates reality. This very much approximates reality. You have someone coming to say, I have a headache and I have been dizzy. It's interruptive, but I'm not scared. That's important, right? It's been worsening since I got up and I can't seem to shake it. Haven't lost consciousness in the past 12 hours, haven't hit their head hard in many years. They deny heart palpitations, narrowing visual field, abdominal pain. Okay, cool. Haven't eaten or drank. They don't feel like it's a great idea, but they don't seem to be afraid of dinner. And, they ate less yesterday around 8 o'clock and half a cup of coffee this morning, but can't remember when. So that very rough summary is how you would probably get it delivered if you were an evaluator. When I said things about consistency problems, there's where they express in the small details. And why electronic tooling and using something like computer adaptive testing is important is I have to legally defend my exams. Process is what I defend. So if I have my raters do what I just did, and what we've all done for most of our careers, jumping around on our scenarios and adding different detail, I have a big threat to validity. If I turn this around and let you read it, now we're all on the same page, and that's a much more consistent presentation. So we're starting from here, and how do we make that look as this graph? Here's our dumbbell shape that I promised you. I want to point out that this is simplified. And remember when I said simple, we need it to be simple because we have an intuitive feel in the trade of assessing people that complexity lives in small places. And if you work in graphs and if you work in networked information, it doesn't take a lot of nodes to make complex relationships. What's going on here? Well, we need you to collect some information. Then we need you to make an intervention. Then we need you to follow up on that information. And what I would like to point out is this narrative leaves a lot of questions. This leaves a lot of discovery that needs to be done because, the past 12 hours is a long time when it looks like you might be bleeding somewhere, or I haven't definitively ruled it out. People have bad memories for what they were doing. People will say, oh no, I didn't lose consciousness, but I got so drunk I passed out. Stuff like that. And we need to work through that. And I need to know that you can work through that before I send you off into the field unsupervised. So what can I do? I can start to get a view of my case design, right? I've added some constraints, some things that I don't want to happen. I'll show you what those are. Some relationships in orange that I would prefer not express. So decisions that I think could be optimized. Those are the things that I would probably want my raters to talk about. with you and say, okay, if we've hit too many of these soft constraints, I want you to do this again. But let me talk to you about why these soft constraints are important. Let me talk to you about why we prefer a different ordering. And if you go to the GitLab page that I'll link at the end, you'll see that I've annotated this graph structure, which you can build for yourself, with those notes that which process constraints are violated and why we don't want to do this. Okay, so we want you to collect some information, then we want you to make an intervention, then we want you to do another set here of information collection, and then we're going to end this scenario. So remember I said this is very contrived. Well, we have this artificial start over here. We have an artificial stop over here. People are going to navigate through. Okay, so Jason, what the heck are these nodes? Why do you keep talking about an intervention and refusing to name it? I want us oriented, to this structure because this will be more of our interest downstream. But here is the content of our exam. I want you to show up and get some basic information out of the patient. So I want you to say, hey, how are you feeling? What's going on? Can I trust how you're thinking? Right, cognitive faculty. Do I see signs of obvious trauma, neglect, self-harm? Can I smell alcohol in your breath? These are things that are very important to establish early because I might need help. And they also very much modify what I can take for granted in the history that you give me. And I'm going to hope, ideally, I'm going to get to these three things before I get to D, because I want to kind of have a feel for what kind of truth you're able to tell. It's one of my instructors will put it. And while I'm doing that, I might want to get some monitoring going. I might want to get some basic information on you. And so we can do these two independent types of things concurrently in time. I can put ECG pads on you while I'm asking you about, hey, what did you do last night? And can you tell me about the last 12 hours? And okay, hold on, will you move this? Okay, you were saying that you went to bed about 11:30, is that right? And we can do these two things at once, and that's okay. We want our providers to be able to be flexible in this way. So we don't want to penalize them for arbitrary decisions. I want to be able to point out when we've crossed the border of efficacy in wandering around. So what I'm really gearing for here, quote, quote, is what I hope you do is I hope you get some information about the person's baseline cognitive faculties and ability to report accurately on themselves and their surroundings. I would like you to measure some vital signs, right? Get a blood pressure, get a heart rate, get an ECG. And since this is a non-critical case, I would actually like you to use the ECG to get a heart rate. So we save a little bit of time here. And I'm just going to put that in because it's easy to identify here. It's nitpicky, but it would be worth talking about if you were doing a performance review. And, so what we're doing this, and eventually I'm going to want you to get the clarification, get your information, and then I want you to make an intervention, right? We are not here to talk in clinical medicine anyway, or at least not the type that I do, but is not to speak ill of the folks who are. That is a different specialty. And when you are feeling dehydrated or possibly like something else is wrong, you're there for an intervention, and reasonably so. So I want you to make an intervention. The reasonable intervention here is we give IV fluids. It's low impact to the patient, and it gives us a nice diagnostic on how they're doing. If they respond poorly to it, my reason for alarm goes way out. And if that happens, I want to see that you respond to it. So we are assessing really general criteria down here. And remember what I said earlier about humans being really bad at observing complex detail. If I put a lot of line items in these last four categories, we are going to be chasing them in ad infinitum, and the amount of attention my raters are going to be able to pay to what's going on in front of them drops down below a viable threshold. So oftentimes we make these big summaries and we say, did they assess categories, physiologic risk, which is what can happen to you because of age, medications, lifestyle contributions. If you've been out till 2 a.m. means something very different if you're 60 versus if you're 20. Losing consciousness means something very different depending whether you're male or female. Those kinds of contributions are important, and I want to be able to see that you can effectively rank them to your patient. And then demographic contributions. Then eventually, I really need you to summarize this into a treatment plan, because eventually we have to treat this patient and we have to move on to other patients. So I have a hope you will do this in a certain order. And I have a hope that as my patients change, your conversations here will change accordingly. That is what the asterisk is for. What we currently do is rely on our rater to say, okay, I've heard enough, you've assessed physiologic risk. Okay, I've heard enough, you've assessed lifestyle. And then, okay, I haven't heard enough for you to assess demographic, so I'm going to not score you on that. And then my hope as a program administrator is the student gets debriefed on that. Maybe it happens, maybe it doesn't. So I want a better way of doing this without having to bombard my raters with detail. And those asterisks are what we'll get to at the end when I mention process improvements. So now we can look at performances, at least in a bit more sophisticated way. By the way, these data are randomly generated, and you can do this yourself. When you have a structured on-the-railed case experience, you can model this awkward dumbbell type structure where your information spaces have high ambiguity, low ambiguity. Even if something goes wrong putting an IV in, this doesn't get complicated. This has obligate low ambiguity. And then again, we go to less ambiguity. And the reason we have less ambiguity here is because we've clarified as we go downstream. That is the value add of a provider, is I take more complexity and I turn it into managed complexity, so to speak. And if you're a healthcare provider, you're probably already cracking up, but that's the idea, right? Is that there's more complexity at the beginning. We get some information, make an intervention. That intervention brings the complexity down, and then we can stabilize and maintain in a more structured, ordered, and understood space. So the question is, how did my candidate, how did my provider go about understanding that space? You can tell there was light discovery in number one. You can tell there was pretty good discovery here. They got to all the items and they violated one soft constraint. So this was a pretty good performance overall. And this is probably a trustworthy one. And remember what I said about computer adaptive testing, taking snapshots over time. Well, I'm going to test you on scenarios again and again. I'm going to resample your performance under similar conditions and constraints. So this is where it gets really expensive. Computer adaptive testing, we do that in an hour by presenting you with different multiple choice questions. In cognitive and psychomotor testing, I have to have you come back to the lab and do another 4 to 15 minute physical exercise. So I need the lab, I need the equipment, I need the personnel, I need the data capture mechanism, lots of cost. But if I stack, say number two, we like number two. Number two is one of my high performers. What I would look for is do a lot of number two's handling of this case. When I record number two, interacting with this particular case, mild hypovolemia, and I start to modify the patients. I start to modify what happened, where, what the history is. Do I still see number two performing like this, or provider two performing like this, right? And is there a way that I can take provider one and nudge them over here, right? Can I help bridge this gap by being more clear about my expectations and how those expectations are met? So here's a couple more examples before we get to the enhancement part. But you can see there's a wild diversity here. I'm sure very few people looked at this list and said, that's a lot of complexity, even though we saw this beforehand, right? That looks kind of complicated. But the other ones compile. So you are all in good shape if you want to use this and look at the code. But we probably didn't translate the complexity in this space and the complexity in this space to a table. And no, we don't. My stakeholders, one of the reasons that I pursued this and one of the reasons it got traction at the university is when I said, hey, I think this list looks like this. A lot of my experts, like Dr. Remskar, and if you look her up, yes, all of those credentials are real. And Marty as well, and my father, they all looked at it and said, hey, I think that's a valid connection. So we went with it. People have been doing this for 40 years. We just didn't see it. We were thinking about this a very different way. We were thinking about the trade. We weren't thinking about math. We weren't thinking about betweenness centrality and graph algorithms. But you can see, as we've walked through, as I've been rambling a little bit, the difference in these cases. There's not much. But when you apply constraints, when you start to see that there's invalid parts that some have and some don't, suddenly it becomes a little more interesting in terms of what could be different about each of these cases and what is different about all this similarity. When I mentioned inference and statistics earlier, that's what you need. I need a really good data model to feed into those statistical inference algorithms and the structures that they require to say, okay, there's some meaning here, there's some difference here, there's not difference here. And ruling in, ruling out is really important. So earlier on, when Amy asked about that dumbbell shape, here it is. Here's these states of near equilibrium that I kept mentioning. They're up here, they're up here. Here's these states of low complexity. And what was mathematically, if you want to switch to, hey, Jason, like what were your difficulties trying to implement this? It's these stricture points. We all, those of us who have worked in machine learning and mathematical algorithmic discovery know that algorithms do not like structures like this. That is called vanishing gradient. That's called exploding gradient when you get here. That is called divide by zero error. That is called by, many names of things that blow up budgets and cause me to lose more hair than I already am. So we need a better data model for this so we don't end up dealing with those problems in post. And so this is the way to start stacking our fundamental information in context. And then we can use it downstream, because I'm sure the acute of you have noticed I really haven't accounted for time. That's okay. We need that, but it just got too complicated. That's another dimension for this talk, but we can use it in our modeling, and I'll show you that in a second. So let's quickly recap computer adaptive testing, and then I'll show you probably the fun stuff, right? The testing approach uses a simple input structure, which is really nice, and it really, really restricts the prediction space. So we can do our expensive discovery and inference offline, and then bring the trained models online. That's so much nicer. And then I don't worry about starting servers on fire and having to pay for them. We lower the demand on a rater's attention a lot by simplifying the input. And then we add a lot of validity by being able to reconstruct context later when we need to do dispute resolution. Experts are extremely expensive to involve, especially the physicians I was working with. And so if we can use them asynchronously, we don't have to get them on site at 11 a.m. on Tuesday. We are much, much better served. When we can aggregate our data, we can feed it to algorithms, we can visualize it, which means we can do quality audits and systemic retroactive reviews. The whole point of this being that we now have a valid way to compare individuals with groups and groups with individuals ad hoc, now or later. So I can compare 10 years ago with today. I can compare one person with an entire state's worth of results because I can just push them all into a graph, right. I can encode them in an aggregatable way. And that's very important for performance development, and because I need to be able to compare. I need to be able to compare ideal to measured, and I need to be able to compare measured to measured. I need to be able to aggregate measured so I can compare it with ideal. And then aggregating measured results gives me an idea of what realistic expectations are. Cool. We get all that. How do we make it better? Because that's like a 40% solution. That's huge, given where we are currently at. Definitely a lot of room for improvements. What about all those asterisks, right? First thing, let's talk about patient generation. This is extremely valuable because right now we're in the business of giving you one patient. I have to get really creative as an evaluator to come up with all of these stories that I have to tell people for 4 to 8 hours a day. I'm seeing 20 to 60, 80 students, candidates. And yes, we all have the tendency of trying to make things unique. It's taxing, it's distracting, there's a lot of conflict. So using something like a large language model to generate patients would be great because we could pull up and say, okay, here's your patient today. And then I could have them generate vital signs and other things that I could use downstream, right? I could say, okay, your patient has this history and we've just applied this treatment. Give me an updated set of vital signs. And now my raters are completely free of having to make up these details that just get confusing and burdensome. But yeah, the LLMs were really bad here. They just did not reflect data sets in an appropriate way. You can see this on one of my linked observable pages. If you want to see the results, you can play with them. There's a database there. There's links in this presentation that you're looking at, and bio-LLMs were really not good at accounting for obvious patient features. And I need fine-grained discrimination. They couldn't do basic discrimination. The problem is, right, what would be good about this is these lists of basic facts are where we spend days with what could take 10 minutes. I need a list, and experts want that list to be right away is the most common problem. It's a big human factors issue to get to a first draft productively. If I could automate or somehow streamline the production of a first draft, we can focus my editors, especially my medical experts, on editing and reviewing, and then we can get rid of the middling and poor accuracy. We can really expand the efficiency of the process. The problem is that this is just really not usable in a credible way. It's too much human in the loop, and that is a real liability to the stakeholder group who would become early adopters. Very untrustworthy of black box methods, of opaque processes already. As one of my physician stakeholders said, we've got enough of those, don't bring any more. If this goes poorly, they're not going to want, they're going to be turned off from it and probably avoid the things that features that have it. So I want to be careful when I introduce this, that it has some ROI for them.
So quick question,
Yeah.
two quick things. So this is super interesting. We've got one question and just a time check, so we've got about 9 minutes left.
Yes, we got about 4 minutes to go. So perfect, and then question.
Awesome. Okay, yeah. Let me do this now. So Lewis is asking if encoding the skills assessment this way allows you to split the skills assessment into parts, so you can have subgraphs, and then discover new ways to run the same checklist.
Absolutely. I did not show that. Brilliant question. Thank you so much for bringing it up. That is one of the really exciting things to me about these structures. So to give you an idea of, I believe what's being asked, I'm going to go back to the simple one because it's just easier to talk about. So remember what I said, we start with A, and that's time step 1. So that's our graph. Our graph is one single node. And what do we know? We know that we're going to B or we're going to C because those are our possibilities. And say that we then go, I'll have to clear this slide up, but we start at A on step 1, and then we go to B, right, on step 2. And so now what do we know? Now our graph is a one edge, 2 nodes, and we know that we can either go back to A or we can go to C. And so if we take this view, as is being suggested, that there's kind of an expanding network of possibilities, yes, absolutely, this could be used for discovery, and I think very meaningfully so. And here's the first place I would point to using it. Not all of these pathways are statistically viable or likely. Chances are very good, like this red edge, this is a flag of how well I've done in my program. This isn't student misunderstanding. This is education. So if I've got a class that's been well trained, this probably has a very low statistical likelihood of appearing. And I might really want to know what the dynamics, and maybe the next class does not have that feature. Well, discovering the dynamics of how that probability changes, I think what was just described in this question would be a brilliant way to investigate that problem. I could be wrong. You can blame me for being wrong. But I see that exact methodology of taking a isolated view, looking out from the node where you're standing, or the subgraph that you have to work with, and the individual dynamics that are possible. That's lovely, and that is really our gateway to doing more sophisticated things with probability. So thank you for asking about that. The answer, hopefully you heard, is a resounding yes. I haven't explored that robustly, but I have left the structure to do that in the GitLab repo. So you can see, you would be able to generate those data sets with the code that I have. So lovely question. Thank you so much for asking it. Does that wrap it up for our questions for the moment, Amy? And then I can speak through the last couple.
Yeah, it does right now. Thanks.
All right. So I mentioned large language models were not good at providing physiologic values. Partly they were reticent to. and they were reticent to provide what may sound like treatment recommendations. Got to give reasonable to both of these. It was not helpful for what I needed. What was more concerning was it was real poor interpretation, and I need professional grade, or at least the ability to start at a threshold that can seed into something well differentiated but finely differentiated. And that was not, LLMs are just not up to this task right now. So they were basically interruptive, unreliable because of accuracy problems, and given their cost, it's negative ROI. So physiology simulators are what I'd really like to push out. This is, if I had to pick a first target, this is where I would go, because I can get those patient generation things done by hand a little easier yet. Physiology simulation is tough. The state of the market is ugly. It's a lot of broken tools and a lot of DIY implementations, but it's real-time physiology data. I can tell you what a patient's history was. It seeds from a health history, and then I say I just gave them 500 cc's of fluid over the next 3 minutes, and it just starts to calculate what the change in those vital signs every sample would be. And so we can record it alongside other data processes, and it's actually a really valuable source of data for debriefing and performance review, because I can show you the impact of your treatment, keeping in mind that no treatment is a treatment on the patient's physiology and critical physiologic metrics. These just turn out to be really sticky and high demand to deploy. There's some ambiguity with the repo's maintainability and viability at scale. They generally fail. I love this Paco Nathan's 30-minute to deployment rule. You're going to struggle with that. And then you need to kind of do your own real-time deployment, which looks something like using the Unreal Engine to run a video game, but you might have to distribute that over the web. So if you can get this done, at a level, you may sink below a cost barrier. It's going to be a big lift. Excuse me. So is there anything that works? I think so. We've tested some of these at university. Warning, these is my opinion, and these are not fully tested. But remember those asterisks. This is what I would say. We need this. We have this high dollar cost, right? We need all this alignment between our stacks and our models and our experts, and then practice changes all the time. So we are constantly changing our wants and expectations. So how do we keep that system updated? Compartmentalizing it is one way. And here is my proposal for sophisticated compartmentalization. Use something like speech to text. Catch 22 years, you got to align the timestamps. That's not a nightmare, but it's difficult. And if you have the speech to text algorithm and its ability to tokenize the discussion, you can tell what kind of discussion went on prior to those. Assess patients' cognitive faculties. Well, what questions did I ask? I've got that now in a speech to text log. We can use things like computer vision for gesture recognition and say, okay, here's when I saw you doing an IV. And that can supplement the rater's observation. That can also provide timestamps for video review, things like that. Simulators have data streams for sometimes when you take the pulse of a simulator, it registers when you did that. They do collect data. They do have APIs for that. Working with them is very difficult, but those things are possible. And really the key points here is it's in theory helpful to have more data sources, but by the time you get through with what it takes to implement, maintain, and deploy these, your ROI is ambiguous and you might be very far down a rabbit hole. So you need to be very careful. It's good to do this, but I would say pick a target area and mine it rather than try to go broad. What we really want to do is try to raise the bar of evaluation so we have better data and we help our human observers apply their expertise in places where it's very useful instead of making up stories and tracking complex lists. But we need to do that comprehensively. There's all sorts of process audits, training, data governance to go along with it. I recommend that you prefer post-processing because it is the type of thing you will be most called to do when you have these record systems, which is defense and audit. And post-processing resembles that. It also gives you a good way to introspect on the data you've collected. Apt over speedy. tests do not come back right away. Don't break that trend and set people's expectations that they're going to get instant results. Give them good ones, and you've used their time well. And then trust is a zero shot. On that note about give people good results over speedy ones, people are going to respond to your investment there very categorically. So there we go. If you want to bring your own method, getting to the point that I just described is not a trivial effort, but it can be done. You don't need to do this in the context of healthcare. Amy brought up a call center workflow. My wife brought up a workflow at a restaurant where she used to manage restaurants. And if you say, hey, I've got an idea, yeah, probably it'll fit because we need a set of possibilities and a time series and then some theory to actually, or some logical glue to stick those together. We might need to spend a lot on alignment because that stack of alignment is deep. And, right? Don't forget, results are proportional to model. All of them are wrong. Some are useful. Focus on the useful. If you focus on useful impact and making sure that your subject matter experts respond to the results in a way that indicates trust, you're off to a good start. Then you can bring in the fancy stuff, which I'd love to talk about. Maybe we do this again. But really, here's the repository slides. I'll have this all updated for you. Thank you very much. And thank you, Amy.
So I think we have to leave it there for now to let people get on with their day.
Yes.
But again, thank you everyone for joining.
May I make a quick note? So if y'all want to get a hold of me, probably the fastest and most reliable way to do that is to email me. Grapht.co, jason@grapht.co. It's in the presentation. But that's probably the best way to get my attention. ADHD and social media are a pretty high miss combination for me. So that's just the last note. Thank you so much, everybody. It was wonderful. And I hope you all enjoyed it like I did.